So, hello to everybody. Let's say thank you for my introduction and of course for the invitation to this great event. I would like to talk about experiences we gained from our clients, and we heard a lot of objects and aspects about smart city and digital twin during the day. I will draw your attention to our clients, and I will show on examples from our clients how they managed their way towards a digital urban twin. So to say, I want to give you examples how they started from their reality to go step for step towards their vision. First of all, I would like to introduce our company. We are a young and rather small company with 20 employees. We are located in Germany, I have got it in Berlin, and we have an office near to Munich, and we see ourselves as experts in CityGML-based 3D city models. So CityGML is an open OGC standard, as Volker Kors right before described, and we are working and developing solutions based on this standard. So we have software solutions which allow you to create, to maintain, to distribute, and to use these kind of city models. And among our clients, there are cities you might know. We work together with Rotterdam, with Helsinki, also with Singapore and many others, and of course with a lot of cities in Germany as well. And I'm myself responsible for business development. So we're a small company, but we're also part of the Catfin Group. And the Catfin Group has shareholdings in many countries around the world. So we have a big brother. We are not only the small 20 people company. So, of course, our kind of starting point is a 3D city model platform, as you can see here. This is just based on an LOD2 city model and CityGML, a landscape model, and giving texture to the model. When our clients start with this, the easiest way of using it is, of course, as information platform. Then many of them use it for economic development and for city marketing. It becomes more interesting if we go into urban planning, a point which I will focus later on, and then just adding urban analytics based on these kind of city platforms, and of course coming to urban simulation and beyond, very similar to what Volker showed. So what you see here is just the way many of our clients walk step for step towards smart city applications and towards digital twin solutions. And of course, we develop things with innovative cities, with research projects and partners, and once we have it, it of course gets available for all the others. So we have a process, we have a kind of democratization in this, because even smaller cities are able to go into 3D because it becomes affordable and beneficial step by step. So first I want to focus on linking existing models and new models. This is one of the challenges we face. So of course we, from our perspective, always start with a city model in CityGML. But if we look into reality, there are other models and other data sources, and of course we want to link it into one platform just to bring the things together. One important point in this position is, of course, the integration of building models, which allows us to include a lot of information into the city model. And of course then we try to make these integrated models available for different applications. Here's an example from the city of Berlin, just showing some collaborative urban planning scenarios, so where you can place your 3D planning into the 3D city model, and this might be available for citizens, for planners, for decision takers as well. And of course, with simple tools, it's rather easy to come to such an integrated model, which allows just a better impression of the scene like you have it in a 2D or in a PDF solution. Of course, if you go to BIM integration and if you use the potential of BIM, I think we will hear afterwards some more about BIM. And of course, it's nowadays possible to integrate BIM planning models in high visualization quality in this 3D city model platform, which really gives you a very realistic impression of what is planned and what the architect wants to build. But on the other hand, also the question is very important. You want to build a building, and then you have what-if questions regarding regarding person comfort, regarding wind streams, and you can also use the BIM building models to use it for numerical simulation. So we wanted to build a framework where you can use the city model, where you can focus on district models, on the building model itself, and of course if you have a BIM building model you can also go into the interior of the model. Therefore we just developed an interface solution which allows us to include these models and to make it available for ANSYS simulation software, which is the world market leader in numerical simulation, which is just an example for what's possible. So we are not only working with this solution, but this is the well-developed example. So on the left side you have a high-quality architectural model, but for numerical simulation of person comfort or climate, you need a simplified model. This is usually a lot of manpower needed work, but if you do this with automated routines, which our tool allows, you come up with a simplified model very fast. And then of course you can go to the initial idea and you can analyze what-if scenarios. So this just brings us towards the next step. I want now to talk about smart applications. I want to show you a few examples about urban analysis and simulation, just what we did in the last time with our clients. The topic which is quite interesting is of course solar potential analysis, and of course the 3D city models are perfect for doing this, and the solution we have in place allows also to take vertical surfaces into account, and of course also shadowing effects from the trees you can see on the lower facades where it becomes blue. So if you have a model and if you have the objects, then you can really estimate which potential you might get from solar radiation. For numerical simulation a year ago, there was a new tool presented, which is called Discovery Live. That's presented by ANSYS, a really amazing tool, and I would like to introduce this tool to you. Here in Seoul or in Korea, we are partnering with T-Zone S&E. You see on the right, they are also providing this kind of solution. So now you see a small picture, again the New York city model as basis, which is of course a very impressive example always to show things on this model. And if there would be a city model available of Seoul, which is affordable of course, we could do the same things rather easily for Seoul or for any other city as well. So this is the web-based city model platform, and now we are looking for a scenario we want to analyze. We are able to select a certain part of this model. And of course, we are able to select different export formats. And what you see is just a visualization of CityGML. That's not a CAD model. We first have to convert this to a high-quality CAD model to use it for computer-aided engineering. And then we can transfer it per click into this ANSYS discovery solution. And this is a real-time screencast. You really can simulate wind fields like this more or less in real time. And that's the idea, so that planners can use it. It's rather easy to use, and you get very fast feedback. So you see how the building reacts in a real urban environment, and of course you also see how the urban environment is affected by a newly built building. So that's not a newly built building, it's just an example. But if you put your BIM planning model or any other model into the city model, you really can do some preliminary analysis, and you can really look at some basic settings, and then you're able to change the position, to change the geometry of the model, and this in a real early stage of development. So this really allows new solutions. And yeah, we are quite happy that the city of Helsinki uses the same solution. They are working on their Kala Satama digital twin project, and they also have a report on that. And for this Kala Satama, they also analyzed the wind field situation, because they built there the first high-rises for Helsinki, and they used the framework we developed, and they did a really good job, and it really shows that it's easy to use. So using the framework is not complicated, and it really supports a sustainable development of city quarters or buildings. Many other topics, we will need research projects to develop solutions, to further develop solutions. So also in flooding we do this. This is a good example because it has many interesting aspects. So of course flooding simulation is in general 2D, and we link it with 3D simulation, which just gives more detailed view at places where it's necessary. But as you can see on the left, we also do a realistic visualization of the numerical result. So it's not only visualization, it's a visualization of the really numerical result. And this is for the information of the citizens, to make them aware of the dangers of flooding scenarios. And we also included sensor data, which might be done over sensor things or other interfaces. And as the sensor data, which is available here for the river, has also a prediction phase, we also can do a prediction. So this is really one step before a digital twin. And of course, having all the data of the CityGML model, it's really able to do some damage analysis and do some risk analysis based on flooding scenarios, which is a lot more, let's say, interesting from an engineering perspective, which is a lot more valuable than just using surface models. But we also have other projects. Just another example. Here's a project we do with the Explosive Ordnance Clearance Service in Germany. We include stoppers, which allow you to simulate blast pressure waves and fragment distribution in an urban setting, and we are now able to do this in a very accurate, in a very fast manner. So we build process change for different kinds of applications, and also with different kinds of applications or solvers. So we are rather free to include almost any solution. Now I want to go to the field of mobility, which is a very interesting and active field nowadays. And of course, if you look to our city models, we are connected to mobility issues everywhere, and the linking element, of course, is the street. We again have CityGML as our base model, and we figured out that OpenDrive is also a standard for this driving street space, and now we are working on interfaces to bring the OpenDrive models also to our city models. And as we have a project with Audi as well, there are of course interesting ideas around how to combine fleet data from cars with the city model data and the OpenDrive data. So the target is virtual testing of the cars for autonomous driving or advanced driver assistance systems, and of course that's a new potential for smart city services as well, or smart mobility services. So I think we are at the beginning there, but as we heard today, the more richer the model becomes, the more interaction of different users and service and data providers, the more interesting it is. And of course, we also come to the point which Steve mentioned. We have a lot of dark data, and we just, if we bring it together, we create new possibilities for the usage just out of nothing, more or less. So here's an example, which is just one of our first tries to integrate a street space model into the city model. This was done by a high definition scanning, and this is a very accurate scanned model, and we converted this scanned model into our CityGML model and made it available within our map. And so we want to then prepare parts of this model for further applications as well. So we see huge potential in those link of city models and mobility applications. This is the reason why we became part of ASAM, which is a standardization organization, and they develop or further develop OpenDrive standards. And we right now have a contract to develop a UML model for the OpenDrive standard. And here just see a few different parts of our top class concept. This will be finished till end of the year, and this allows us in the next step to develop an interface from OpenDrive to CityGML, and this allows us to enrich the city model with the street model, and the other side around as well. This allows us to bring the city model to the street model also. Here I brought a screenshot from our Audi project. It's located in Ingolstadt, as Audi is. And what you see in the screenshot is the basic city model and a detailed street model with vegetation, with traffic signs, with the lanes and all the lane markings. And this should give you an impression what's possible nowadays and what we want to achieve in automated way. So not handmade, really into automated processes. The car you see on the screenshot is just following a real trajectory of a real testing car outside, and then we have added a viewshed analysis, so what the driver sees is green, and what is not, what can't be seen by the driver is red, and we are of course able to bring this dynamic scenario into the 3D environment, and of course you also can have a view from inside the car as you see on the right. I also brought a small video, which is not Ingolstadt, but it's the same topic. You see the animation of a traffic simulation. So we do not do the traffic simulation, but we are able to use the street network and to provide it for the traffic simulation, and then we are able to take the result of the traffic simulation and bring it into our 3D environment. And in addition, we are able to link it with further analysis, like here with this viewshed analysis, and you see in this dynamic scenario which parts, of course, are seen and which parts are shadowed by other cars or persons or vegetation objects. And these are different layers into the city model platform, and on the right, on the bottom, you have a steering thing where you can just change the speed of the animation, and where you can really look at the different things of it. So now we are coming step to step towards something like a digital urban twin. So what is missing right now? So we heard in the first speech today that, of course, there has to be a critical mass, that it's interesting. So having only LOD2 and not 5 years old, it's complicated because it's not up to date, it's not detailed. So we really have to struggle hard to keep the model updated and, of course, to link further information with the model. What you see here is the underground modeling of Rotterdam. They already have more objects in the underground than above Earth. But by integrating the different things, by integrating underground lines and supply networks, it really is a new dimension of application which became possible. And what you see here is a section into the model. You really see the vegetation object with the estimated root volume, you see infrastructure lanes, and of course it's not only a visualization, it's an object-oriented model. You can click on every object and you see what this is, and of course you can link this to your export system as well. And of course, if we have the possibility to enrich the detailing of the model, this also makes it better and more interesting. And then, of course, sensor integration, very important. Also an example from Rotterdam, they recently integrated a lot. I'm not sure how many they are, but that's not important. They use an open OGC interface for the sensor integration. Probably they're also using standard things as well. And then they are really able to integrate sensor data, which is live data. You see the speed on these different traffic sensors. And you can work with it and you can provide it for different applications out of this platform. Again, so I'm coming to the end, and integration of sensor data is one big step towards a digital twin, but to do this in real time or to do this live is just the next step. And what you see here is just the buses, which are also linked live into this map. And you see when the bus is red, he's a little bit delayed. When he's green, he's just on time. And you see that the platform is updated. And as we heard yesterday in the keynote, 5G will support this real-time and live applications by a huge extent. And I think this really enables new possibilities for the futures. And I guess that the developments we did altogether during the last decade just really support all the other developments in the 5G area or elsewhere. So I believe that the solution will be not only one city model platform. I think that it has to be a system of systems, as Steve already mentioned. So this is just a schematic scheme of a general approach, how this might be. And we followed the vision that we want to link all these different platforms, independent by the company. And we want to link these different platforms by open interfaces and by open standards, so that everyone can control and contribute, and so also that every platform can be included. We believe that the future will not only be one platform by one of the big providers doing everything for every department. We believe that a lot of departments have their different world and their different platform, but if we use interfaces which are open source and which are standardized, it makes data available and it makes data moving, and we really are not living in silos anymore. And this is the way we see the future, and as we follow this way, I think we really can make huge benefit out of it. Thank you very much.
Thank you for your presentation. Question time.
트로미터 강의 잘 들었습니다. 특히 인상적이었던 게 ANSYS 디스커버리 라이브에서요, 그 공기나 그 바람길의 그 시각적 표현이 굉장히 인상 깊었습니다. 제가 또 궁금한 건 크게 두 가지인데, 기체나 유체 역학 쪽의 학자들이 그러한 공기 흐름에 대해서 많이 연구를 하고 있어서 기존에 2D라든지 3D 모델이 그쪽 전공 분야에 있는데, 이걸 해석하실 때 그쪽 모델에 있는 그 포맷이라든지 그걸 와서 디지털 트윈 그 플랫폼에서 해석을 하신 건지, 아니면 이 모델에서 새로운 방안으로 유체 역학의 흐름을 만든 것인지 궁금합니다. Do you understand what I...
Yeah, thank you for your question. Good question. Let me say the following things to this. The simulation is done within this ANSYS discovery framework, and into this framework you also can evaluate the results. You can generate graphics, you see streamline plots, which allows you to see areas of high wind speed and areas of high wind pressure. And of course, this is, as I'm from the area, I'm a civil engineer and I know about numerical simulation. So this is not that's simplified, but that's real time. And of course, it's not high-end simulation with perfect quality, which takes you a big calculation cluster and a lot of time. So this is simplified, but it's real time, and it gives just the planner an impression about some basic results, about the basic behavior. So it's really not the high-end simulation with high fidelity turbulence modeling. I know that this is a lot of effort, but this also takes weeks for modeling and for analysis. So if you start with this, and if you just think about, okay, let's do it like this, let's put the model a little bit more on the left or on the right, let's do it higher or smaller, and you get a basic feeling for the behavior of the model. And then in the next step, you of course should do it in high quality with other ANSYS solutions or with other solutions which are on the market. Did I answer your question?
Yes. Thank you. One more question. Next page 그 프로 픽션을 분석을 했는데요. 유사한 질문입니다. 아까 사실은 정확도나 정밀도보다는 실시간으로 이제 보여주는 분석하는 데 중시한다고 그랬는데, 이 홍수 모델 사진을 보면 그 홍수가 나는 실체감을 느껴지는 건데요. 가령 이 홍수 분석할 때 1차원으로 분석을 하게 되면 사실은 현실세하고 전혀 안 맞습니다. 왜냐하면 백워터 효과도 있고 지형에 대한 프레셔의 압력에 의해서 사실 물 흐름이 완전히 달라지기 때문에 홍수 분석 자체가 바뀌는데, 이런 모델을 할 때 그러한 공학적인 개념이 들어가 있는지 궁금합니다.
So the basic for what you saw is an engineering model. We cooperated with the chair for hydrodynamics of the University of Dresden. They are specialists in all kinds of water applications. And the basic is up-to-date simulation. So most of this kind of simulation is done in 2D, but on high quality. So we use the landscape model, we use the bathymetry of the river, we use the roughnesses of the surface depending on the different kind of usages. But the innovative thing is that we bring this information together into our platform and we enable the user to select a certain area which is then transformed into a model which is usable in a standard code, whether DHI, MIME or another solution. And this is, so the 2D simulation is, as professionals do it, our benefit or the innovative thing from our point of view is that we bring different sources of data together, which makes it easier and faster for the user. And of course we want to bring the result of the professional system back to the city model platform to inform the decision takers, to inform the citizens. And if we analyze different water levels of these flooding scenarios, and if we have the sensor data of the river, and for the sensor data of the river also has a prognosis model, because we know what water is coming from above. We can of course give a prediction of what is coming into the city, as we have the pre-calculated flooding scenarios. Did I answer the question?
Thank you for your answer. You have 2 more questions.
Thank you for a nice speech. I have just one question about your visualization for 3Ds. Usually I want some questions always because you use 3D models, but some of your result is more focused on the vertical relationship of their data, your analysis result, not a horizontal relationship. So for example, airflow, like kind of I can see that every height, how wind flow and then speed is changed, certain height, but it's a more vertical, like a vertical relationship, not horizontal information, continuous information. Usually I can see from the 3D models. Also for the viewing angles, for example, like a human is a viewable cube, like a human site is a viewable cube, but it's more like a 2.5 dimensional result for driving angle for your presentation. So my question is, there's some reason you use not to kind of a 3D result, like a 3D result visualization or other problems?
I'm not sure whether I understood your question. So we try to bring the results into the 3D model.
Yeah.
And we have different possibilities of visualization within our city model platform. As you have seen for the viewshed analysis for the moving car, this is done in our city model platform in real 3D. For the ANSYS Discovery, it's done in the ANSYS Discovery framework and into their 3D system. But I'm sorry, what was the question again? So did I answer your question?
Yeah.
Or? Okay, thank you.
We have 1 more question. Let's go ahead.
예, 지금 디지털 트윈이라는 제품은 결국에는 현실에 가장 가깝게 만든다. 그리고 그걸 통해서 최소한의 비용을 가지고 저희가 미래를 예측해서 그렇게 한다는 내용인데, 앞서 질문하셨던 분 중에서 저도 질문을 드리고 싶었던 내용이 현실에 맞지 않는 예측, 보면은 시뮬레이션해서 보긴 좋은데 그렇지 근데 현실과 맞지 않는 결과물이 나왔을 때 오히려 하지 않았을 게 더 나은 그런 문제가 발생할 수 있는데, 그런 문제에 대해서 어떻게 생각하시는지 첫 번째 궁금하고요. 두 번째로는 디지털 트윈이라는 게 어쩌면 굉장히 큰 자원들을 이제 실세계에 맞추기 위해서 수요가 되는데 경우에 따라서는 굉장히 단순한 어떤 도식을 가지고도 현상을 충분히 설명할 수 있다고 생각합니다. 아까 보여줬던 버스 같은 노선 같은 경우는 굳이 굉장히 큰 빌딩들을 다 보여줄 필요 없이 노선만 보여줘도 충분히 할 수 있는 건데 과연 어떻게 해서 디지털 트윈이라는 게 역할이 정말 필요한지에 대해서 좀 말씀해 주시면 고맙겠습니다.
Okay, thank you for your question. How to answer? We believe that it makes no sense, as you also said, to analyze and to do everything in 3D. But 3D is necessary for some kind of applications, and 3D has certain benefits. So we don't want to restrict ourselves, so we want to build a 3D platform. And we want to integrate as many information and models as possible. But then we want to link this model platform with different solutions or different solvers. We do not have traffic simulation. There we rely on the specialists. And they of course do not need the 3D environment, they only get the road network. So if we build a process chain for such an application, they can define what they want out of the city model platform. They say, okay, we want the street network. Well, but we want to have the street network on the digital landscape model because it's interesting to see whether the road goes up or down. We are not interested in the 3D building environment, so then they do not get it. So we tried to supply every different kind of application with the data they need out of this platform. And then we tried to bring it back. And of course, to achieve a digital twin, it's of course a hard struggle. So the more details and the more models and the more sensors we get into the model, the more interesting it becomes. And of course, as we experience nowadays, you have really the point of a critical mass, which was mentioned in the first talk today. Because if you just start with a few-year-old CityGML LOD1 model and a landscape model, this is for a lot of applications that's not detailed enough, that's not up to date enough. And so it really becomes interesting when you link it with more data, if you can update this. So we experienced that a lot of clients struggled hard 5 years ago to build up the city model. Now, this is rather easy to build a city model, just check. They are now struggling hard for updating the model. So they, in their surveying departments, they of course have to establish processes which allow them to partially or in total update the model because the city changes slow but rapidly. And of course they now have solutions for updating the model. So the next step of most of them is to link it with sensor data, to link it with additional models like street models and networks, utility networks. This is the process we experience from our client.
You have just one more question.
예, 좋은 말 감사합니다. 첫 번째 질문하신 분은 보충주점입니다. NC2에서 보면은 윈드플로우를 설명해 주셨는데요. 도시마다 많은 미규, 마이크로웨드, 미규가 있고 건물 지역이 있는데 많은 모델링이 있는데 그런 모델링을 NC2의 유저가 디파인하는 입력을 어떤 인터페이스를 해가지고 다른 어떤 사건이 발생했을 경우 이벤트가 근데 오염물질 확산된다든지 이런 이벤트를 그렇게 비주얼라이즈하게 3D 볼 수 있는지 궁금합니다.
Of course, we can integrate different solvers. So we are in general open for the integration of all different kinds of solutions. We, of course, would provide a 3D platform and would provide a user interface for some simple options and for selection of a certain area, for defining a scenario, and then we would just convert this part of the model and to give it to the solver of the solution. So there we are in general absolutely open to different kinds of solutions, and we have just to build a user interface for some different options. We work with ANSYS because ANSYS, as the world market leader in computational engineering, is of course a very reliable partner, and ANSYS Discovery is of course a very impressive, fast and simple solution. So there might be in special kinds of applications other solutions which are good, but we believe that the ANSYS solution in this place is really an interesting option for our client.